Good everyone. In this video, I'm going to be covering question 2 from self-study question sheet number 4. And in this case, we are dealing with a situation in which we have a variable x, and x follows a specific type of distribution. So far, I believe in the unit, when it comes to probabilities, this is a fairly new topic. This is something which has only been covered in the past week or possibly 2 weeks max. Prior to that, when you got introduced to probability, you were looking at just standard random variables, and in particular, when you look at the types of variables you were looking at for those probabilities, they were, and I'm trying to think of an occasion when it wasn't. They were all to do with categorical variables. So the probability that someone makes an error, doesn't make an error, if it's this person or that person. These are variables that fit into different categories and as such are categorical. Here we're dealing with a different type of variable. So in this case, the variable x isn't categorical, it is a numerical quantity, and it can take upon the values 0, 1, 2, 3, or 4. So in terms of the numeric side of things, this is what we call a discrete value. So discrete just essentially, or should I say, for lack of a better definition, I think a really easy way to remember it to start off with is that it refers to a whole number representation. So you'll see 0, 1, 2, 3, these are all whole numbers. If we're dealing with a situation in which we've got continuous variables, i.e. values in which there can be decimal places, then we start to look at things like normal distributions, t-distributions, and so on. There's going to be quite a few that we're going to go through, that I will also address in the videos, and you will go through as part of the remainder of the course. So in terms of being able to identify this, you just have a look at the variable, you have a look at what values it can take upon. So here, firstly, we identify it's numeric. Second, we identify that these are all whole numbers. Therefore, we're dealing with a discrete probability distribution. So knowing that impacts upon a number of different things, in particular like how we calculate the average, standard deviation, how we calculate probabilities, and so on. So the first question is, in this case, we're giving an incomplete probability distribution, or an incomplete discrete probability distribution, as we now have classified. We've got a missing value. So we've been given the probabilities of each event occurring, except for when the event is that x is equal to 4. So in order to be able to solve this, we just use a fundamental principle of probability theory, which says that, that the sum of the probabilities has to be equal to 1. So in a given sample space, if there is a set of events that can occur, if you then ascribe probabilities to each of those events, and you add up all of those probabilities, they have to be equal to 1. So in this case, that translates to probability x is equal to 0 plus the probability x is equal to 1 plus the probability x is equal to 2. Ignore that error message. Probability x is equal to 3 plus the probability x is equal to 4 must equal 1. So all we need to do is we just need to sub in these values. So 0.2, 0.25 plus 0.25 plus 0.2 plus probability x is equal to 4 is equal to 1. So if I add these values together, I've got 0.25, 0.25, which is 0.5, and this one should be 0.2, sorry. So this comes to 0.9 plus probability x is equal to 4 is equal to 1. So now if I want to solve for the probability x is equal to 4, because we've got an addition here, I'll subtract it onto the other side. Probability x is equal to 4 is equal to 1 minus 0.9, which is equal to 0.1. So now, given the incomplete probability distribution, by using one of the fundamental axioms of probability theory, we're able to solve for that unknown value. Okay, so the second component of the question is that we need to calculate the expected value. Now, within probability theory, the expected value is interchangeable with the term average. And in fact, actually, what you see in probability theory is that the average is rarely referred to. It's most commonly referred to as the expected value. So in case that sounds unusual to you, just remember the average is what you expect to see on average. So therefore, the average is the expected value. So whenever you see expected value or this E of x, just remember it's just an average in case you're worried about understanding it. And the way that we calculate it is that we take each value upon which x can take, so 0, 1, 2, 3, we multiply it by its corresponding probabilities, as we have here. I'll just quickly fill in this unknown one, now known, and then we apply this operator, the sigma operator, which is the sum of. So you don't have to do it this way, but I'm just going to break it apart into small operations. I think it's easy to interpret. And the first thing that we're going to do is we're going to calculate x multiplied by the probability of x for each of the different values. So what that means is we're going to do 0 multiplied by 0.2, 1 multiplied by that, and so on and so on. So let's do that. 0 multiplied by 0.2, which is 0. We then have 1 multiplied by 0.25, which is equal to 0.25. The next one is 2 multiplied by 0.25, which is equal to 0.5. The next one is 3 multiplied by 0.2, which is 0.6. And lastly, we have 4 multiplied by 0.1, sorry about the formatting, which is equal to 0.4. So now what we've done, let me just set to that, is we've calculated this x times probability of x for each of the different values. What we will now do is apply that sum operator and we'll add them up. So therefore the expected value, is equal to, sorry about that error message just coming up, that becomes equal to 0 plus 0.25 plus 0.5 plus 0.6 plus 0.4 and 0.4, and that is equal to, so that's 1, 1.5, 1.75. So we have the expected value is equal to 1.75, or the average value is 1.75. The next component, part C, is to find the standard deviation. So there's a rule, obviously I'm sure you guys have probably seen this rule so far, which is that the standard deviation is equal to the square root of the variance. Now when it comes to defining variance again in the classical probability, is that it's equal to the expected value of x squared minus e of x all squared. So remember, this e of x is just the expected value, so we've already calculated that. So we've already got 1.75. So in terms of this formula, we've got this bit in the brackets already done, we just need to square it. What we need to find is e of x squared. Now, this is the formula for e of x squared. You'll see that it's very similar to what we have for e of x. The only difference is, in this case, we don't raise x to any power. And here, because we want e of x squared, we raise it to the power of 2, or x squared. So what I'm going to do is very similar to what I did for the expected value. However, there's going to be 2 columns. I'll firstly do x squared in one column, and then I'll do the column of x squared multiplied by the probability of x. We'll then apply the sum operator, find that, and then we can sub it in to find the variance of x and then the standard deviation. So this is equal to 0 squared, which is equal to 0. Next one is equal to 1 squared, which is equal to 1. This one is equal to 2 squared, which is equal to 4. This one is 3 squared, which is equal to 9. And then lastly we have, and sorry, this is, let's just notice that, 0.1. We've got 4 squared, which is equal to 16. So now we've done this component of the formula, we now need to do this multiplied by this. So we'll do this in the next column. So that's equal to, so it's going to be 0 multiplied by that, 1 multiplied by that, and so on. So 0 multiplied by 0, which is equal to, 0.2, which is equal to 0. We then have 1 multiplied by 0.25, which is 0.25. The next one is 4 multiplied by 0.25, which is equal to 1. And then in the next one, sorry, no, it's not going down, is 9 multiplied by 0.2, which is 1.8. And then lastly we have 16 multiplied by, equals 16 multiplied by 0.1, which is equal to 1.6. Sorry about all the mistakes. Okay, so now we've done this component, we now need to just apply the sum operator. So e of x squared, put on the next line, x squared is equal to 0 plus 0.25 plus 1 plus 1.8 plus 1.6. And that comes to, so this is 3.4, 4.4, wait a second, 3.4, 4.4, 4.65 if I've added that up correctly. Okay, so now we've got e of x squared, we can now find the variance of x. So the variance of x is equal to this e of x squared, which we've already got, 4.65, minus, and then the expected value squared. So that becomes 1.75 squared. Okay, so I just need to quickly pause the video for... Okay, so I'm just, sorry, I know that was a bit choppy there. I'm just now going to calculate this value. So 4.65 minus, and then we want to do 1.75 squared. So close brackets, and we've got that is equal to 1.5875, 1.5875, and therefore the standard deviation of x is is just equal to the square root of the variance. So that's equal to the square root of 1.5875. So quickly doing that on the calculator, taking the square root, that comes to roughly 1.26 with 2 decimal place after 0.26. Okay, so that's how we calculate the standard deviation. We've also shown how to calculate the variance, the expected value, and then if we have an incomplete, to fill in incomplete components of a discrete probability distribution. So if you have any questions, please comment on the Facebook page, or you can comment here, subscribe to the videos, and yeah, I hope that was helpful. Okay, bye.